So problem number 36. Here we go. So in this one, it says that you have a box of textbooks weighing 25 kilograms. So box of textbooks. Sorry, this is really hard to write on while keeping it, like, I don't know. So it's 25 kilograms. And it's resting on a loading dock that makes an angle of alpha with the horizon. So this is the ground down here. And then it has the angle alpha. And then the coefficient of kinetic friction is 0.25. So mu sub k equals 0.25. And then mu of static, or S, equals 0.35. Okay, and then it wants us to figure out, as alpha is increased, so as this rotates upwards this direction, what is the minimum angle at which the box starts to slip? So we know that this minimum angle is going to be when the force of friction, so force of friction, equals the force of gravity in the x direction, because we're going to define this to be positive x and this to be positive y, so that way things are just like in line with the ramp. Makes it a lot easier. So the first thing we want to do is figure out what each of these is going to be. So the force of friction equals our coefficient of friction times the normal vector, and then, or the normal force. So this is going to be mu s times f sub n for the normal vector, or the force of the normal force, and then that's going to be equal to the force of gravity, which is going to be 9.81 times 25 kilograms, and then that's going to be multiplied by the sine of the angle, I believe. So if we draw this again, just like the free body diagram, we have, actually we don't need the ground, because this is a free body diagram. Woohoo! So you have your boxes. I'm just going to get lazy and draw a circle. And then you have the force of gravity pulling downwards. Actually, if we reorient this so it's matching our coordinate system here, so this is positive x and this is positive y, you're going to have the normal force, which is going to be pushing opposite of gravity. So it's going to be pushing something kind of like that, and then, or not opposite of gravity, and then you're going to have gravity that's kind of come down here, and then that's going to be at the same angle alpha that the ramp is at over here, because your gravity is going to be coming down right like that, and then the angle between those two, between the normal force, which is pushing up like this, and gravity is going to be alpha. So when you rotate down, gravity just moves over alpha. So it's going to be sine, because sine equals opposite, which is your force of gravity in the x, over your hypotenuse, which is just your force of gravity, and then this is going to be your force of gravity in the y over here. So that times sine alpha, and then over here the normal force is going to equal your force of gravity in the y direction, because that's how much is pushing down into the or no, that's wrong, sorry. The normal force is going to be straight up, and that's going to equal your force of gravity in the y, because it's not moving up or down. So force of gravity in the y direction is going to be 9.81 meters per second multiplied by 25 kilograms, and that gets you your overall force of gravity, and then you multiply that by the cosine of alpha, and then that's also multiplied by the 0.35, which is your coefficient of friction up here, and then that's going to be equal to 9.81 times 25 sine of alpha. And then you'll notice on both sides you have a 9.81 for gravity and a 25 for the mass, so both of those are just going to cancel out because there's no addition or anything. So 0.35 cosine of alpha equals sine of alpha. So the easiest way to find alpha here would be to divide both sides by cosine. So you get 0.35 equals sine over cosine is tangent of alpha. So you take the arctangent, or tangent to the negative one, the inverse tangent of 0.35, and that is going to get you your alpha, which is also equal to 19.29 degrees. Alright, so I believe that was the answer to the first one. The minimum angle that it starts to slip, alpha, equals 19.29 degrees. So that's part A. And then the next thing it wants us to figure out is, at this angle, find the acceleration once the box has begun to move. So for this one, what we're going to do is we're going to just take the force of gravity in the x direction. Let's just get rid of all of this real quick so we have a bit more room to work. So to find the, what was it again? The acceleration. So force equals mass times acceleration. We know the mass, which is 25, times the acceleration, and then we can find the force because the force is going to equal, or the total force, the sum of the force in the x direction, because we're working on the plane here, is going to equal the force of gravity in the x direction minus friction, force of friction. And then, so the force of gravity, we already calculated that out to be your 9.81 meters per second times 25 kilograms times the sine of alpha, which is 19.29 degrees. And then from that you subtract your gravity, or not your gravity, your friction, which now that the box is moving, we're going to use this coefficient for instead of this one, because this is the kinetic or moving friction. So it's going to be 0.25 times your normal force, which is your force of gravity in the y direction, which is equal to 9.81 times 25 times cosine of 19.29 degrees. I know that kind of ran off the edge there a little bit, but that all is going to equal your force in the x direction, so your sum of forces in the x direction. Now one thing with this, we already decided that force in the x direction equals your mass times acceleration. So since we have mass in both of these, we can just get rid of the 25 in all of these, and we'll go ahead and rewrite this to be 25 times your acceleration, just to keep everything all looking pretty in the same. And then at this point you can go ahead and plug in all of your numbers there, and then your acceleration, I believe, let me just double check real quick, but I believe it should come out to be 0.926. I'm going to go ahead and just type that in real quick just to be safe. So you have 9.81 times the sine of 19.29 minus 0.25 times 9.81 times the cosine of 19.29. Is that right? Yes. Okay, that actually comes out to be negative 1.388 meters per second squared. And that's your acceleration. So your acceleration is equal to 1.388 meters per second squared. So this is a negative acceleration here because when I set up the coordinate system, I set positive y to be up the ramp, and since gravity's pulling it down, it's actually going to be pushing it this way or accelerating it in the negative x direction. So that's why that's negative. If you set up your coordinate system different, it would be positive still. Okay, and then the next thing it wants you to find is, at this angle, how fast will the box be moving after it has slid 0.5 meters along the loading ramp. So for this part, the easiest way, maybe not the easiest, but the way that I did this one, is you have your equation delta x equals v naught t plus 1/2 at squared. So we have our acceleration already. V naught is 0, so that part all just goes away. And then we have our delta x, which is 5 meters. So 5 equals 1/2 times 1 point, yeah, whatever. I'm just going to not write that because it's a pain. So 1/2 at squared. So then you can multiply both sides by 2, so 10 over your acceleration equals t squared. So you take the square root of all of that, and then you get the square root of 10 divided by 1.388 meters per second, and that gives you a time of, sorry, that's not all equal, time is equal to 2.684 seconds. And then from there you can move on to your next equation for velocity, because that's what it's asking. So velocity is going to equal your acceleration times time plus your v naught, or initial velocity. So again, we already have both of these, so you can just take this time that you just got and multiply it by your 1.388 meters per second, and that gives you a velocity of 3.726 meters per second. And that's that.